Dear third grade students, hopefully you are in the best of your states. This is our third recorded lecture for the module entitled Computer Applications in Management and Economics. Today I continue teaching the economic part of the module. Recorded lectures are to be used in conjunction with your textbook. In the current presentation, we are going to resume some points from Chapter 1 because these points are closely related to today's lecture. Today's lecture is concerned with using graphs to summarize economic data. Today, we will not cover all the types of graphs discussed in Chapter 4. Only we will discuss two types, namely the line graph and the histogram. Visual presentation of data is an important way of summarizing its main features. It is not interesting for anyone to read hundreds and hundreds of observations included in the original dataset. There are several types of graphs including line graph, bar chart, pie chart, and histogram. However, before discussing the importance of using graphs to summarize economic data, let's resume together the types of data, their structures, and their scale measurements. Data could be divided into quantitative and qualitative. Quantitative data could be measured or counted numerically, such as quantities, prices, ages, length, weight, interest rates, number of students in your class, and so on. Qualitative data could be organized into sets or categories. Examples of these categories include gender and religion. In such a case, data cannot be measured numerically, but can be either classified into categories according to the characteristics that identify the variable. Quantitative data also could be divided into continuous and discrete data. Continuous data may take the form of fractions and decimals. Examples of continuous data include delivery, distance, and weights of students in your class. Discrete data, on the other hand, can only take integer values. Thus, discrete data could be defined as count numbers. The number of flights between Cairo and London is an example of discrete data. In order to examine qualitative data and use it in regression analysis, it's important to convert this data into numbers. The question is how to do so. It's quite easy to do so, but first let me remind you that such data arises often in economics when choices are involved. For example, these choices include to buy or not to buy a product, to take public transport or a private car, to join or not to join a union. Responses to these choices are yes or no. Economists convert these qualitative answers into numeric data. Let me explain this point. Assume that a labor economist asks employees whether they join a union or not. This economist may set yes equals to 1 and no equals to 0. In such a case, he creates a dummy or binary variable that takes only two values, 0 and 1. Thus, he could use this binary variable in the regression analysis. Data available for empirical analysis could be classified into three structures: time series, cross-section, and panel data. Time series observations show the values that a variable takes at different times. A time series is associated with a particular frequency of collection of data points. In other words, a time series is collected at regular time intervals such as daily, weekly, monthly, quarterly, and annually. An economic or financial time series may consist of up to 4 components. These components are trend, cyclic increments, seasonal variations, or irregular movements. A trend shows a general and long-term tendency of the time series data to increase or decrease over time. Cyclic increments display up and down movements over periods longer than a year because of business cycle. Seasonal variations are periodic short-term fluctuations over a period of less than a year. Seasonal variations are associated with hourly, daily, and weekly data, and of course monthly and so on. These variations are due to natural forces, religious ceremonies, or man-made conventions. Finally, irregular variations of time series data are purely random. They are short-term fluctuations. They are not predictable. An example of such movements include the dramatic fall in the number of international flights to China and the dramatic fall in its industrial production in response to the Wuhan coronavirus. Another example of irregular variations of a time series is the sharp decline in the Egyptian stock indexes in early 2011 because of the unexpected political unrest. Cross-sectional observations on one or more variables are collected at a single point in time. Micro and labor economists often work with this data structure. In other words, they deal with data of individual units. These units might be students, households, firms, states, or countries. Unlike time series data, the ordering of the cross-sectional data doesn't matter. Panel datasets have both a time series dimension and a cross-sectional dimension. Subscripts I and T are attached to an observation to represent these two dimensions respectively. Assume that we have a dataset of 3 companies' profits over a 3-year period from the year 1990 to the year 1992. Thus, if we have an observation with the subscript 1 and 1, this means that the profit of the first company in the first year. If we have another observation with the subscript 1, 2, this means that the profit of the first company in the second year, and so on. Panel data can also be collected on a geographical basis. For example, we might have GDP data for a set of 20 countries over a 20-year period. Economists working in issues related to economic growth often use panel data. In general, economic and financial variables are organized under 4 categories. These categories are ratio scale, interval scale, ordinal scale, and nominal scale. A ratio scale variable satisfies 3 criteria. These criteria are: first, the ratio between two values of such a variable is a meaningful number. Second, the distance between two values of this variable is a meaningful number as well. Third, there is a natural ordering of its values. Most economic and financial variables, such as prices, GDP, profits, belong to this category. For an interval scale variable, it doesn't meet the first criteria of this ratio scale variable. However, it meets the last two criteria. For example, a time period extending from the year 2000 to 2010 satisfies the last two criteria. An ordinal scale variable satisfies the third feature of the ratio scale variable, that is to say, the natural ordering of its values. An example of ordinal scale variable is the classification of income classes into upper, middle, and lower income classes. Finally, a nominal scale variable has none of these characteristics. Examples of these variables include gender and religious beliefs. Regarding chapter 4, we are going to cover 2 points of the first section. In other words, we will discuss summarizing quantitative data using a line graph and a histogram. A line graph is also known as a time series graph. It enables us to plot the values of an economic or financial variable against time. In this graph, time is measured on the horizontal axis, and the values of the variable or the variables in which we are interested are measured on the vertical axis. A time series graph enables us to visualize how a variable has evolved over time. A time series graph is capturing the time evolution of a variable and its main components, even if the dataset is so large. Here we have a dataset of 590 observations. This dataset includes monthly observations of the exchange rate of the UK pound against the US dollar over the period starting from January 1947 to October 1996. The screenshot shown in the current slide displays only 24 observations of this dataset using a table. This subsample represents 4% of our total observations. However, the subsample is small, but the table is not informative. Since we couldn't identify the main features of the data easily by looking at the numbers. For these reasons, graphs are employed when dealing with large data sets to enable us summarizing the main features of the data. These monthly observations of the aforementioned exchange rate are displayed in screenshot 4.1. Note that the horizontal axis measures time, whereas the vertical axis represented the values of the sterling pound versus the US dollar. Now, from this graph, it is quite easy to detect the main features of this time series variable. For example, the Bank of England adopted the fixed exchange rate regime, in which the British pound kept fixed against the US dollar until the end of the year 1971. Moreover, we could see that large devaluations of the pound sterling took place in September 1949 and November 1967. Then it gradually depreciated as it floated downward through the middle of the 1970s. However, it jumped from $1.68 in December 1976 to $2.42 in October 1980. Finally, depreciation of the pound sterling is noticeable for the most of the remaining period. Now it's your turn to identify the main features of the time series variable displayed in the screenshot 4.2 in your textbook. What is the frequency of this time series variable? What trend does this variable show? Is it a downward or an upward trend? Could you identify any other components of a time series? Refer to the 4 components we have earlier discussed in the current presentation. In the case of cross-sectional data, using a histogram is an appropriate method to summarize the data, whether it is discrete or continuous. A histogram is a pie chart showing the number of data points that fall within a specific class intervals. Note that a histogram can also be used to summarize the main features of time series data, such as stock returns. This is shown in your textbook. In a histogram, class intervals are represented by the horizontal axis, whereas the frequencies are represented by the vertical axis. Hence, a histogram informs us about the shape of the data distribution, showing any outliers. By outliers, we mean the most extreme values. That is to say, an outlier could be defined as an observation that is numerically distant from the rest of the data points. Generally speaking, shapes of distributions could be divided into 3 broad shapes. They are modal distributions, bimodal distributions, and multimodal distributions. Let's define them using simple words. A modal distribution is a distribution that has only one peak, whereas a bimodal distribution has 2 peaks. Finally, a multimodal distribution has multiple peaks. The histogram displayed in the screenshot 4.3 shows the cross-sectional data on real GDP per capita in the year 1992 for 90 countries. Real GDP per capita for each country is measured in terms of US dollars using purchasing power parity exchange rates. The histogram reveals that the data is clustered around 2 levels of real GDP per capita. The first bunch is large. In this first bunch, data points cluster at 2,000 US dollars. The second bunch is small. In this bunch, data points cluster at 14,000 US dollars. Growth economists describe this clustering of countries into rich and poor clusters as the twin peaks phenomenon. These features of the data cannot be easily identified by looking at the raw data. However, we could easily identify them by looking at the histogram. Modal distributions could be classified into 3 shapes with respect to skewness. First, symmetric distributions. Second, positively skewed distributions. Third, negatively skewed distributions. Let us talk about the symmetric distribution. If the data set is equally distributed either side of the highest frequency, then we could say that the distribution is symmetric. In other words, it has zero skewness. A special form of the symmetric distribution, wherein the data is plotted as a bell-shaped curve, is known as the normal distribution. Many naturally occurring characteristics such as human heights and weights are normally distributed. For a positively skewed distribution, if a histogram exhibits a punching to the left with a long tail to the right, this means that the data distribution is positively skewed or skewed to the right. Thus, a positively skewed distribution has a few extreme data points in the positive direction to the right of the most observations. In contrast, for a negatively skewed distribution, if a histogram shows a punching to the right with a long tail to the left, then the data distribution is negatively skewed or skewed to the left, the same meaning. Hence, a negatively skewed distribution has a few extreme data points in the positive direction to the right of most observations. Knowing the shape of the distribution has important implications in many fields, especially in the field of financial markets. Assume that there are two return distributions for two individual stocks or two indexes. Both indexes or both stocks have the same variance, but one is negatively skewed and the other is positively skewed. If you are a risk averse, which stock would you invest in? A risk averse investor would prefer the positively skewed returns distribution over the negatively skewed one, even if the latter is associated with higher expected returns compared to the former. Could you guess why? Think about this point. Now it's time to test yourself. Refer to figure 4.3 in your textbook. The figure shows students' scores in a quiz of economics. Do you think that a large number of students has to resit for the exam? Why? Justify your answer. Kurtosis is the other indicator of the distribution's shape. Kurtosis measures both peakiness and heaviness of tails of the distribution compared with the normal distribution. Figure 4.5 illustrates modal distribution shapes in terms of kurtosis. There are three shapes, namely leptokurtic, platykurtic, and mesokurtic. If a data distribution is more peaked around its mean with fatter tails compared to the normal distribution, it is termed leptokurtic. In contrast, if a data distribution is less peaked around its mean with thinner tails compared to the normal distribution, it is said to be platykurtic. Finally, if a data distribution is neither flat nor peaked with normal tails, it is termed mesokurtic. Suppose that many people in your neighborhood suffer from obesity. There are competing health clubs or gyms in your area. Each offers many available weight loss programs. You are to help your friends to choose from the available weight loss programs. Bear in mind that selecting a program from those being offered is often influenced by the distribution of the time spent to lose weight by participants in different programs. Assume that there are two distributions of the time spent to lose weight by participants. The first distribution is elliptic, whereas the second is plateautic. Which one would you recommend your friends to adopt? Before answering this question, refer to figure 4.5. It would help you to answer this question. Now let's answer this question together. Elliptic distribution of the time spent to lose weight by participants indicate that the program was very effective in weight loss. Regarding a plateautic distribution of the time spent to lose weight, it indicates that the weight loss was gradual. Hence, overweight people and of course your obese friends are likely to be more attracted to elliptic weight loss program. By covering this point, we reach the end of our lecture. Thank you.